Hey guys, welcome to another video. Welcome to the channel. If you haven't subscribed, please go ahead and do so. It's very much appreciated. I'm on my way to 5K. It would be nice to get to 5K subscribers. But you know, look around the channel, see what you like, see what you're interested in. Give some feedback and suggestions for just newer videos that will help me to make better videos for you guys. But in this video, we're going to talk about BigTreeTech SKR3, my thoughts on it, and we're going to also talk about my Frankenstein BLUE BOY. All right, so as far as the SKR3 go, I did do a little preview on it. So if you want to go back to that video and watch it, I did talk about it in a little detail, but this is just my thoughts on it after hooking it up to my project here. Again, very easy to use, just like the SKR 1.4 before it and the SKR2. Very easy to use, especially when it comes to clipper. I don't have much experience in marling with these boards because I mainly primarily use clipper firmware as my 3D firmware of choice. But for me, in my experience, again, the setup was easy. Standard config, you know, hook it up, make sure everything is wired in properly, make sure all of the pins are correct. Depends on what feature you're trying to activate, but there's no difference in terms of going from the SKR2 to the 3 for me, because as you know, with clipper firmware, you don't actually use the processing power of the board. You actually use the processing power of the Raspberry Pi or a computer or whatever device that you may be running clipper on at the moment, right? But if this was marling, you probably have much more better performance here, because I think this is running the SKR3 is running a ARM Cortex M7 CPU at 480 megahertz. So it's much faster than the 1.4 turbo, which was running 120 megahertz at that time. So if you're running marling firmware, it's probably much beneficial to you to have the SKR3. Again, faster processor. There's a lot more features. It has EEPROM on it, which is 32 kilobit. Input voltage, of course, is 12 volt to 24 volt DC. It is compatible with marling and clipper firmware. It has Wi-Fi interface, the ESP12S or the ESP07 or the ESP32. So you can run those on here as well natively. The difference really is between the SKR3 and the SKR3 Easy board, which is also their next line of board as well, is you have a selectable jumper selectable, which you can select different pull-up resistors from 4K7/2K2. So okay, so you can, if you guys understand what that means, I'm not quite sure what that means. I'm guessing that's a resistor thing that's there, but it does support a both of them do support PT1000 thermal sensor, right? So temperature sensor, which is getting popular lately. I usually use your standard sensor, which is your NTC generic 3950 beta temperature sensor. But if you wanted to run a PT1000 sensor, you can definitely run it on here. That's both on the SKR3 and the SKR Easy board. The difference also too is the fans. Now, I like that BigTreeTech has now included controllable fans in their new boards. Unlike the 1.4 turbo before, you couldn't really control more than just one fan. I think there's one controllable fan on that. Now you have up to 3 controllable fan, including 2 CNC fans, which basically are on all the time, right? But I like that they include controllable fans. However, I have a problem. I wish they would allow for each fan channel, you can run it in 12 volt or 24 volt or 5 volt. In this case with SKR3, you can run it in 12 volt, but it's all 3 channels that will run in 12 volt, not a single channel. So I wish they would fix that. So my suggestion is for them on the next update to allow selectable fan voltage for each channel, not just one selectable fan voltage, and it runs through all the channels, right? Because, you know, we like to mix and match. We're hobbyists. We like to mix and match, whether that's 12 volt, 24 volt, or 5 volt fan, right? So we just want that option to run that on each channel separately and not all together, not tied in all together. So I think they should just fix that one, just like they do with the Octopus board. The Octopus board allows you to run those fan channels separately at different voltages. So I would like to see that implemented on the next XKR board. Another thing I don't like is the USB-B. I don't like that. I think we're in a different time, or modern time. I think they should be using USB Type-C, in my honest opinion. That's where we need to be heading. So I think that's a no-go for me. That USB Type-B is no-go, BigTreeTech. So I think you should implement USB Type-C. It's more seamless. It's what everything is moving forward to. So I'm looking forward to see the next XKR have a Type-C board. Now, their board also support vast majority of driver out there. So right, whether that's TMC 5160, TSMC 2209, TSMC 2225, pretty much all of those drivers, the 2208s, all the popular ones out there, they're all supported by this board. Even your old driver like the A4 9888, etc., they're all supported by the SKR3. So again, nice board. I think this is more capable with Marlin, because like I said, I'm using Clipper, so I'm not using half the capability of the board. I'm actually using the Raspberry Pi here to do all the processing. But if you're doing you know, Marlin firmware, you'll probably see the benefit of this new board with the extra processing power of the new processors that they're using, right? So that's just my opinion on it. Like I said, tons of features. I haven't went through half the features yet, but on the general scale, it's a nice upgraded board for those who are running Marlin preferably. But for me, like I said, the Raspberry Pi is what's doing the job for me here, so I'm not really using half the capability of it. However, I do like some features. One of them that I want to mention here that it also supports is CAN bus. So there is a button on the board that allows the USB-B to become a CAN bus hub, which is really nice. So that means you're future-proofing the board, which is really nice. So if I decided that I wanted to use the CAN bus capability of this board, I can go ahead and do that, which is really, really nice. So kudos on BigTreeTech for implementing that on a nice cheap board here. Okay, but other than those gripes, I think it's a great board, and so I'm gonna move on to the next thing, which is my printer. So, and again, thanks BigTreeTech for reaching out and kind of sponsoring the board for this build. So, Blue Boy is what I'm calling it. So this is a very interesting printer. Let's go through what it was and what is now. It was originally a Sunlu S8. Okay, it was originally a Sunlu S8 that I turned into a massive, or not really say massive, but a larger size Voron switch wire. Then I decided to break it down because I wanted it to do something else with it, right? Because I built a switch wire before. It's cool and all, but I wanted something of my own vision. And this is what I came up with. So basically, this is kind of a Frankenstein bed slinger. I've always wanted to run dual Ys. So dual Y motor. I like the setup, especially for big beds like this. The purpose for the dual Y is to double up the torque of the motor, and to just allow for higher acceleration on big beds like this. But let's go through basically what I have here. So I'm using the Trident skirt. So if you guys are familiar with the Voron Trident, I'm using the Trident skirt setup. The specific size of the skirt is from the 250 bill. So 250 size bill is what I'm using the skirt from. I'm using, this is the Sunlu, like someone on Thingiverse made a better belt tensioner than the stock belt tensioner. So if you look at the Sunlu S8 belt tensioner, it was like metal and you didn't have much adjustment. I like these much better. They're much cleaner. So basically I'm reusing this. I'm using also 9mm belts in this case. I designed my own linear rail mount for the stock plate. So the stock plate underneath, I designed my own mount for that, which was really nice in Tinkercad. This adapter here that's sitting on the plate, I got that from Rat Rig. So that was the Rat Rig V-Cast, I want to say. That was their bed flapper, their massive IDEX bed flapper. I took that from them to use. So as you can see, there's inspiration from different printers here. So we have Voron, we have Rat Rig, we still have a little bit of Sunlu here. We have the Kevin Sam belted Z mod, which is fantastic. Definitely worth it if you want to eliminate linear Z bending and just eliminate lead screw wobble. This is a nice way of doing that. Really, really nice mod. Kudos to him for that. And these stepper mounts for the Y, I'm using, these are from actual Pursa. So these are modified Pursa Y stepper mount. Okay, so as you can see, I'm getting inspiration from all over the place to make this a reality. I think it's really pretty cool that, you know, that you can just put a bunch of design together and make something unique, and that was the purpose of this. The spool holder is from the Tictac build. So this was designed by Squirrel Brain for the Tictac. I like the way it's designed. It's really clean, so that's why I'm using it at the top here, because there's no other place to mount a spool holder. So I just picked that location. I think it's, you know, nicer up there. I'm using the stock bed because it's lighter. If I use a 6mm bed, there's no way this thing will be moving this fast. And I'll tell you the speed in a second. But as you can see, it's moving very quickly, and the stock bed, bigger, thicker bed, aluminum bed, would have caused layer shifts already. Okay, so I'm using the stock bed. It's being powered by an external MOSFET, 25 amp MOSFET. Instead of putting the pressure on the board to power the bed, I'm actually using an external MOSFET to power the bed. Okay, linear rail size is 450 millimeters. They're MGM12H. They're 450 millimeters on the Y-axis and on the Z-axis. The X-axis is 400 millimeter linear rail. Okay, and they're all MGM12H. As far as the HotEnd setup, clearly using a BL Touch, aftermarket BL Touch, pretty cheap, but it works. Using the Pheatus BMS, Dragonfly BMS, using the Sharper Mini that was designed by the guys over at Annex Engineering. Really great extruder. And I'm using a 12 volt 50-50 fan, 50-50 in fan, and it's overvolted to about 14 or 15 volts to push a bit more air. And I'm using the Tryon duct. And this whole HotEnd assembly is from the Hero Me Gen 7. This is Medium Man design, Medium Man 3D design. It's not a bad setup. Aesthetically, I'm not a fan of it. Aesthetically, it's functional, it's great, but I'm not a fan of it aesthetically. So eventually this HotEnd setup will change for something more aesthetic to my pleasing, but at the moment I don't have that much of a CAD skill, so I had to go with other people's setup. So that's something I need to work on to design my own liking here, but it's doing great at the moment. So overall, I like it. It's working really well. The reason for this design was I wanted to push the speed of the printer. And in order to do that, it has to be heavy and rigid. At this point, this thing is very heavy and very rigid. It is super heavy. It's like easily 50, 60 pounds on its own. I want to say close to that. It is printing currently at 8K acceleration all around, 150 millimeters a second. Print speed, the infill speed is 200 millimeters a second at 8K. At 20K. The travel speed is 20K at 500 millimeters a second, right? That's why you see like zipping back and forth like that. So it's pretty quick for a big bed to be moving that quick. I did run the input shaper tests, and on the X-axis I'm getting almost 10K acceleration. It was 9,000 700 for the maximum acceleration suggested, and that was MZV, which is one of the lightest input shaper algorithm suggested. And then for the bed, it's a bit lower. Again, it's a bigger bed. It has a lot of vibration issues, so the acceleration was a much lower on that, which was, I got like 3900, and the suggested input shaper algorithm for that was EI on that, which is not too bad. So, but you might be wondering why I'm able to push this printer and make it move so fast, because I'm using a technique called, which no one has made up the technique, but I'm just giving it a name. I call it speed optimization. Basically, I'm putting the acceleration where it needs to be, right? So in travel acceleration can be as fast as it wants to be, because the hot end and the bed is just traveling to the location it needs to deposit the filament, right? So at that point, the speed can be as fast as you can get it. However, when it comes to the printing speed, you have to work with the input shaper suggested limitation or suggested acceleration, right? So that's what I'm doing. I'm working with the suggested acceleration while pushing the speed where I can push it without deteriorating the quality of the print. So that's what I call speed optimization. So what I mean is that you don't have to print fast everywhere, right? This is not a Quartz Y where you can really get away with printing fast in perimeters, outer walls, inner walls. It's a moving bed. So you still have to be mindful that this is more likely to introduce a lot of artifacts, a lot of ringing when the bed is moving that fast. So speed optimization just really means putting the speed where it needs to be, where it's not important. So infill can be fast, travel can be fast, the inner perimeter can be fast, but the outer wall has to be slowed down, right? Because you still want to maintain the quality of the print. And that's what speed optimization is. Believe it or not, those who are running Bamboo printers, that's what Bambi does. Bamboo Labs printers are fast, yes, they're fast pre-built printers, but they're also using the same technique I'm using to get away with it, right? Because if they print at 20K at 200 or 300 millimeter all the time, you will see massive ringing in their prints. And a lot of users are not aware of that. They're thinking it's fast all the time, but no, they're just using speed optimization as well to make sure that they get the benefit of putting the speed where it needs to be and slowing it down where it needs to be, right? Again, those who are 3D printer enthusiasts already know what Bamboo Lab is doing, but new people don't really understand this, and so therefore they think it's the fastest thing since sliced bread, right? And this is no shade thrown at Bamboo Lab. I think they have an amazing product, but the users just don't understand. Some of them just don't understand what's going on. So again, speed optimization matters. And so I just wanted to share my printer with you guys. This is what I came up with. This is my Frankenstein, and I hope you guys like it and appreciate this. But like, again, what I find is the limitation for this printer is definitely the moving bed. And so in this case, Quartz Y is superior. Even with a moving bed in the Z travel, it's still superior to a moving bed in the Y travel, right? And you just can't run away from the mass. You can't hide that mass. When I was printing at 20K acceleration of 500 millimeters a second, the edge of the bed here would literally vibrate like this every move. And so that just shows you just the limitation of a moving bed, right? It's just, you cannot run from the inertia and the back and forth. However, what's stopping this bed from layer shift right now, this print from layer shifting, is because I have two motors working in tandem. If I had one motor, this would have layer shift at the speed I'm printing at right now. So adding two motors help with that torque, help provide that stability of it not losing positioning while moving very quickly, while moving this big bed very quickly. And so therefore it's just doing a great job of just supplying enough torque to keep the print going, right? So again, just wanted to throw that out there and share my little design. For anyone who have a Sunlu or even a CR10 that may want to attempt this, I'll throw out the STL that I've compiled. I'll go ahead and just kind of put it down in a link. Just if you want to do something similar or design something similar like this, or use the STL I've gathered to attempt this as well. So, but yeah, guys, but I'm at the end of my video. I want to again shout out to BigTreeTech, thanking them for providing the board for this little experiment here. I'm really liking it, honestly, because I can say I have one of the fastest, biggest bed printer moving around at the moment on YouTube, right? There could be other people out there having fast printers too. Now, if this was an Ender 3 with a smaller bed, you probably could get away with a lot more speed, especially using dual motors. You probably could get away with a lot more speed. But with a big bed like this, with a lot of mass traveling back and forth, you know, you're definitely gonna have some limitation there. Even if I wanted to print at 20K at say 500, it's not going to turn out good. The print is not going to look good at all. It's probably going to come right off the bed. So you just have to be mindful there. But again, it was a fun build. I did enjoy building it. I'm excited about it. And I'm going to keep playing with it in the background and just kind of observe any changes. I'm still going to keep tuning it. But for right now, I just wanted to share that with you guys that it's completed. It's done. I just need to put the cover. There's a little undercover underneath that I need to put it up to enclose the whole bottom area, and it should be completed. But yeah, guys, so hope you enjoyed the video. Remember to like, subscribe, share, and I'll see you in the next one, guys. Peace.